1, which means, okay, the first section of Unit 7. We're going to be talking about chemical reactions today. Okay, let's hope you have your brains on and ready to go. We're going to start by describing a chemical reaction. Okay, what is a chemical reaction? Well, chemical reactions are occurring every day, all the time. Some examples might be, let's talk about rusting iron. How did I miss that I? Okay, also, when we talk about digestion, what's always happening for us, we're going to break down glucose. Okay, nice and easy couple things that we're talking about that you see all the time or know of every time. Okay, here's another one that's kind of fun. We're going to do some exploding of hydrogen. Okay, that one's kind of fun. Big flame ball. It's kind of fun. Not bad. And the other thing that it happens all the time, but we don't realize it, and that's the homeostasis in living organisms. Homeostasis is simply the ability to maintain a fairly constant body temperature, environment, health. You get the idea. So when we move on, there's some evidences of chemical reactions that happen all the time. One of them would be the substance changes colors. That's a chemical reaction. Okay. Next thing would be maybe the pH changes. Okay. Maybe it's a change 1 or 2 points. Maybe it's changed 10 points. Who knows? But if the pH changed, you no longer have the same substance. Therefore, a chemical reaction has happened. The other thing that happens a lot is it gets hotter or colder. That's what we call an energy change. Okay. Now, we'll talk about exactly what type of energy changes gets hotter and what type gets colder at a later time, but it could do either or, and that is, it's not always a sign of a chemical reaction, but it's a sign one could have happened, because a lot of times we just heat things up. But in certain instances, and we'll talk about that at a later time, that definitely becomes an evidence of a chemical reaction. Okay, and the other thing that happens is what we call the formation of a precipitate. Okay, a precipitate is a solid that kind of comes out of a liquid. Just all of a sudden, there it is. Okay, that's a real nice thing to have. And also the production of a gas. Don't get that confused with the releasing of gas, as in boiling, but the production of a gas. All of a sudden, we have a new gas present them. Okay, we have to some representation of a chemical reaction so we can. You like that horn? I do too. Okay, an example might be hydrogen and oxygen forming water. Okay, we have to have representation of that, and here it is. We're given what's a chemical equation here. Okay, and with chemical equations, we have two sides. I'll talk about that here real quick. We got the left side, and we got the right side, separated by this nice little arrow thing. Okay, so I'm going to take those off of there so I'm not getting anything. So the things on the left side are what we call, oops, let me turn on my pen again, what we call reactants. Okay, they're the things that come together, or that they're the things on the left that cause the reaction to happen. They're a part of the reaction itself. Now on the other side that we talked about earlier, okay, that is called a product. Now if you think back to a factory, okay, a factory has a lot of people working in it. They're taking different pieces, which would be the reactants, and they're putting them together to create a product for the company to sell. Okay, does that make sense? It's exactly the same concept that we have here in chemistry. And then they're separated by the arrow. Okay, that arrow means yields or produces. Okay, yields is not like the yield sign on a street that tells you to slow down, leave everybody else the right away. What we're talking about, yielding, is giving birth to, production. Okay, it produces that final product. Okay, you can't have a product until you've had some sort of production. So if you can remember that, you're going to be in good shape. Now, we talk in chemical sentences. Now, the names of elements or compounds, because it's not always an element. The names of elements or compounds are used to indicate substances and the amounts used in a reaction. For example, going back to water, okay? Here we're talking about hydrogen and oxygen and this compound over here known as water. Okay? So in our chemical sentence, you notice there's a 2 here, right? And there's a 2 there. And then there's these little 2's here. Okay, we're going to talk about those 2 real quick. Okay, so this 2 right here, okay, and we're going to call that molecules. Now we've been talking in moles, but today for the sake of argument we're going to call it a molecule. So 2 molecules of hydrogen gas react with, if there's no number it means there's 1. 1 mole of oxygen gas to produce or yield 2 molecules of water. Okay, 2 molecules, 2 molecules, 1 molecule. Got it? Easy enough. Okay, now, the names of the elements or compounds are used to indicate substances and the amounts used in a reaction. I need to get my pen going again. In a reaction. Okay, so here we once again 2 hydrogen molecules combining with 1 molecule of oxygen, producing 2 molecules of water. So we want to put this into a word equation. Easy enough. Here we go. What is it we're combining? We're combining hydrogen gas and oxygen gas. Oops, forgot my Y. And what are we producing? Water. So our word equation would be hydrogen gas plus oxygen gas produces water. Okay. Now that's something easy enough. Another example. Here we go. We're talking about Fe plus O2 producing Fe2OS. Okay. We notice that we have these things afterwards. We'll talk about those here in just a second. And we also notice that we have this, and we'll talk about that here real shortly. But right now, let's just look at this example. Okay, the products. Products are over here. We got our products. Okay, our reactants. You're right, the other side, those are reactants. Okay, I'm going to clear those off real quick as we talk about the next. The word sentence. Okay, the sentence would be 1 iron molecule mole, okay, and 2 oxygen molecules or mole produces 1 iron oxide. Okay, the word equation would be iron and oxygen produce iron oxide. Okay, now the other symbols I was referring to just a minute ago. Now remember, this has to be a subscript, so maybe I have O2S. Okay, the S means it's a solid. That's a hard one to figure out, isn't it? Okay, this is an L, not a 1. That means the substance is in which state? Correct, a liquid state. Okay, so now if we got oxygen in a liquid state, that'd be known as the liquid oxygen. Then we have the aqueous. You may not be familiar with aqueous, but it's signified by having an AQ at the end, which is the first 2 letters of aqueous. Okay, an aqueous solution simply is something dissolved in water. You think about aqua and aqueous, same thing. It's not truly a liquid, and it's not truly a solid. It's an aqueous solution. The solid has been dissolved into water. Okay, now here the last one we have is a gas. Okay, the G and the G for gas. Hard to follow, I understand, but you know, I think you'll get used to it if you think about the phases of matter, and then aqueous being the other one that we're not talking about. Of course, we're not putting in platinum, we're not putting in Einstein Bose, and we're not putting in that great other one that we have there. Okay, let me clear the screen. Okay, and the other symbols, the plus sign means we're just going to separate two elements or two compounds or something in our chemical equation. That's all it means. Could be on the reactant side, could be on the product side, could be on both. Okay? And the arrow, it's going to separate, as we've talked about, our reactants and our products. Okay? Because it's the thing that creates a production. And if we have a double arrow, it means going both directions. That means the reaction can go both directions, or we call that reversible. Okay, good enough. Now, if the arrow has something on here, that means it's a change, which this stands for a catalyst. We'll talk about that on the next slide. In this case, the catalyst would be heat. Okay, this indicates that heat is used in the reaction. Heat itself is not changed, but the reaction needs it to take place, or to speed it up at least. Here, if I have an element symbol, in this case plutonium, or platinum, excuse me, that means the formula indicates it's used as a catalyst. Anything on top of the arrow is considered to be a catalyst. And a catalyst is just simply something that speeds up a reaction without being changed. So let's take that off. Once again, we said the catalyst is a substance that speeds up a chemical reaction, but it's not used in the reaction, which means whatever it was still is there. It just happened to help speed it up. Okay? An example might be this one. Now, this catalyst, for some reason, is way up there. It should be right on top of that arrow. I'm not sure why it's that way, but it is. Okay? Where we got iron and oxygen producing the iron oxide that we talked about earlier. Okay? This needs to happen in the presence of water. Let me pull that off. We'll come back up here. We'll write speeds again because I got it sloppy down below. Okay? So this happens in the presence of water. Okay? And the water helps speeds it up. So all the product in here is this. All the reactants are there. Okay, so we need to know those things. Okay, the phase state, the iron's a solid, the oxygen's a gas. Of course, the water doesn't matter what it is, but it produces a solid rust. Now, when we write chemical equations, we always take the reactants, an arrow, and then the products. Okay, we use word equations. Okay, we have word equations for like the iron and oxygen producing iron 3 oxide. Whoa, wait a minute, what's this thing? When you see something in parentheses, a Roman numeral, that tells you the charge of the cation, okay, which would be a 3 plus. Oxygen, as you know, has a charge of a 2 minus. Okay, so we use a crisscross method when writing this out into a chemical equation rather than a word equation. And it's going to look something along the lines of this. Iron, iron. Oxygen, oxygen, remember it's a diatomic, produces iron oxide. Here's the 2 to go with the iron. Here's the 3 to go with the oxygen. Okay, there's our chemical equation. And if we put it using our phase states, iron solid, or solid iron plus gaseous oxygen produces the solid iron rust, or iron oxide, excuse me. Okay, now let's talk about the law of conservation of matter. Really, if you think conserve, it means to keep. Okay, so we're going to keep matter. What that mainly says is matter cannot be created, it cannot be destroyed in any chemical or physical reaction. It's only changing what it's attached to or how much is attached to it. Okay? But we still have the whole process. If I cut something in half, I still have the whole thing. It's just in 2 different pieces now. Okay? So when we're talking about the law of conservation of mass, it means we have to balance our equation. Balancing our equation means both sides of the equation must have the same number of atoms on each side. Okay? They have to have the same number of atoms of each element on both sides. But there's a rule here. There's a catch. Okay? You can only change the coefficient, okay, to adjust the balance of an equation. You cannot change the subscripts. So instead of saying cannot, I'm going to make a bold statement and say you never never change the subscripts, because the subscripts are what identify the substance as what it is. Okay? Never change the subscript. Okay, we got carbon, solid carbon, and gaseous oxygen produces gaseous carbon dioxide. Now, do we have the same number of carbons on each side? I've got one on the left, I got one on the right, because this 2 right here only refers to the last element in front of it. Okay, so I've got one carbon and I've got, one carbon here. I've got 2 oxygens, I've got 2 oxygens. So we're balanced in this equation. This one we look at real quick, you can tell no, I've got 1 iron and 1 iron, that's okay. But here I have 8 sulfurs and only 1 over here. Now, a lot of people say, oh, that's easy, let's just put an 8 here. I'm sorry, that's wrong. Do not do it. Okay, so let's clear that out of there. That never happened. Okay, in order to get 8 here, remember on the last slide I said you can only change the coefficient. The coefficient is the number in front. Since there's no plus sign between the iron and the S, it has to go in front of the iron. But now that means I have 8 sulfurs, which is right, but now I have 8 irons, so I need to get an 8 over here to balance that out. Now I have a balanced equation. Okay, so keep that in mind. I'm going to take those 8s off, and this is real important for you to understand. Remember the Brinkelhoffs. Okay, the Brinkelhoffs right here. That means that we have bromine, we have iodine, we have nitrogen, we have chlorine, we have hydrogen, we have oxygen, and we have fluorine. Okay, all of these elements are diatomic, or 2 atoms bonded together in nature. Okay, so they're diatomic elements in their natural form. Have to remember the Brinkelhoffs. Okay, get that done and you're going to be good. Okay, and here you can change what? That's right, the coefficient, but the coefficient tells you how much, or the amount. So you can change the amount, but not the identity. Okay, the amount is the coefficient, 8 and 8. The identity is the subscript.